Bristol Bay is home to the largest run of sockeye salmon in the world. It is a treasured resource that has defined a way of life for indigenous Alaskans for thousands of years.
Did you guys see those two that caught right when we set it out?
I know, I was telling him those are fish going out.
These different regions and these different peoples are connected by the migration of salmon. This is one of the great migrations on Earth.
Salmon is what has sustained people for thousands of years in Alaska. How we could protect that is very important to me and to a lot of the people who live here.
The Alaska Department of Fish and Game, in partnership with the Bristol Bay Science and Research Institute, has been using DNA genotyping solutions from standard biotools to help sustainably manage the fishery.
Salmon are a migratory species, and so fish caught in one region may originate in a different region and impact those people. And so these people are related by these fisheries and the impacts upon them through salmon. And DNA as a natural tag is very good at understanding that relationship and these impacts.
Our lab goes out and does baseline sampling. We'll go to where they're spawned out. We know they're from there. Take samples there, bring them back, do genotypes, figures out which markers represent a population.
Genetic markers unique to the river or stream in which they were hatched are identified in the salmon. As the adults return from the ocean to their natal streams, on-vessel genotyping of sample catches from the Port Muller test fishery, located at the entrance of Bristol Bay, predicts which rivers the salmon are bound for. Fisheries managers can then direct commercial fishing boats to the best fishing districts.
So the Port Muller test fishery is like a 7-day preview of what is to show up in the actual commercial fishing districts.
The Port Muller fishery, the way that it works is having this transect going across the bay and taking these samples at very defined stations across the transect that they're fishing.
You take that random sample of fish and you characterize those catch samples for the same genetic markers that you have in the baseline, and you identify that in this catch sample, 42% is bound for the Kwijak, 18% for the Nushagak, and whatever that catch sample happens to be. Traditionally, the way this project worked was those samples would fly from Port Muller to King Salmon to Anchorage.
Fish and Game staff have to get them to the plane. The plane's got to be able to fly to Anchorage, and then we got to get them from that airport to the lab and make sure someone's in the lab. We were on call all the time. We didn't know when the samples were going to be sent or when they were going to get here.
And that was really what slowed the whole process down. And sometimes getting the samples off the boat and into Anchorage took longer than us actually running the data through our lab.
We're like, hey, we want to do this crazy project and put an instrument on a boat. We sailed out and it worked.
Okay, so let's see. There's the EP1.
Now, with the onboard genetics, it takes a day or two at the most to get that information. And so then we get, something that looks like this, that has the proportions of fish.
The industry can decide, there's a lot of fish going to Naknek Kwijak. We're going to divert our tenders and our resources towards that district. Fishermen want to know when to move from one district to the next. So that's really the benefit of the genetics.
The development of these TACMAN SNPs and this chemistry that allowed us to become the high-throughput lab to analyze samples in the way that we're able to now to really understand what's happening in these fisheries.
We've set escapement goals. So escapement goals are the amount of fish that escape past the commercial fishery and into the natal streams where they can spawn and propagate the next generation.
And what is the ideal number of spawners to ensure that we're sustainably managing fisheries and we have fish for the future, but also that we maximize benefit to Alaskans in terms of harvest opportunities?
We think it's improving the Bristol Bay run and the forecasts to which river system those fish are headed. That's very, very important.
This fishery started in 1883, and we had the best run ever in 2022. To me, that's sustainability right there. So in 100 years, maybe we can have the best run again.
From sustainability and conservation to genetic health and pathogen detection, Standard BioTools is committed to providing fish biologists around the world with the genotyping tools they need to help their fisheries thrive.
The genetics lab is continuing to grow in its applications. One of the really great things about that is that it brings the actual analyses that are used, like the laboratory work and the post-lab analyses, it brings that back to Alaska, and to Alaskans.
The technology got faster and better.
We just got an X9 in a few weeks ago. This is a growing science, and it's just kind of fun to see it changing all the time. And I think we're a part of that.
The thing that I am really looking forward to is continuing between the department, BBSRI, and Standard BioTools, collaboratively working together to move this project to the future.
We are we people, not I people, and we want to live as that, as Alaska Indigenous people.
Well, the most important thing, continue to have these sustainable runs. Our culture can continue to be built around salmon, not just for our sustenance, for all that it means to people.